All right, boys and girls, we're moving on to the very last example, example 9, and it's solving a trig equation. So it says find all solutions of cosine of 6x minus cosine of 3x equals 0 between 0 and 2 pi. Okay? All right, here we go. Since we're given the difference, we're going to be using the sum to product formulas, and we're going to be using cosine of u minus cosine of v equals -2 sine of u plus v over 2 and sine of u minus v over 2. Okay, so this is the formula we're going to be using. So let me just rewrite it and plug everything in. So here we go. We should have -2 sine of 6x plus 3x over 2 and sine of 6x minus 3x over 2 equal to 0. And then this will simplify to -2 sine of 9x over 2, and just leave it as a fraction. Sine of 3x over 2 equal to 0. And then remember, we are solving, so maybe divide both sides by -2. And then this will give us sine of 9x over 2 times sine of 3x over 2 still equal to 0. Okay, so basically we just got rid of the -2. Okay, so now that we have our trig functions by themselves, what we could do is apply the zero product property. So it said each factor equal to 0. Okay, let me graph my second whiteboard. Okay, so now I have sine of 9x over 2 equals 0 and sine of 3x over 2 equals 0. So basically, you can look at your unit circle, and when does sine of what angle gives you 0? And that happens at 2 points. It happens when x is 0 and x equals pi. So basically what we're going to have is we're going to write 9x over 2 equals to 0 and 9x over 2 equals to pi. But then this is going to be the same thing here. So we're going to have 3x over 2 equals to 0 and 3x over 2 equals to pi. Because remember, sine of 0 will give me 0 and sine of pi will give me 0. Okay, so same thing here. So we're going to set those equal. So since we're going to be finding all the solutions between 0 and 2 pi, basically I should be able to get multiples. So I should have 9 of x over 2 equals 0 plus 2n pi. Okay, and I could do this for every single one. But what I'm going to do is I'm going to solve for these two first and these two, just because I know I don't have enough room. Okay, so let's put it this way. Let's just concentrate on these. So I'm going to solve for 9x over 2 equals pi plus 2n pi. Okay, and the reason why I'm doing that is because I want to solve for every multiple between 0 and 2 pi. Okay, so in order for me to solve for n, what I'm going to do is I'm just going to multiply all of this by the reciprocal of 9 over 2. So I'm just going to multiply by 2 over 9. Okay. And let's not get too ahead of ourselves. So we'll work with one and then we'll work with another. Okay. So basically now what I'm going to have, by the way, I'm multiplying to everything. So if I distribute 0 times 2 over 9, that's just going to give me 0. So I can just cancel that out. And then this will give me 4n pi over 9. Okay. And then I'm going to basically do the same thing here because I'm trying to isolate x. Okay. So I'm going to multiply by 2 over 9 to the left-hand side, and I'm going to multiply it to the right-hand side. So 2 over 9. So if I solve for that one, I'm going to end up with 2 pi plus 4n pi all over 9. Okay. Okay, so I want to find all solutions between 0 and pi. Okay, So I need to find exact solutions, not general solutions. And if I were to leave it here, we have general solutions, but they restricted our domain and they said between 0 and 2 pi. And notice that 0 has a bracket and 2 pi has a parentheses. That means we want to include 0, but we don't want to include 2 pi. Okay. We just kind of want to end there, but we don't want to go exactly at 2 pi. So n is going to be an integer, any integer. So when n is 0, okay, when n is 0, we're going to have 0 times this over 9, which will just be 0, okay? So 0 would be one solution. When n is 1, we're going to have 4 times pi over 9. When n is 2, we're going to have 8 pi over 9. When n is 3, we're going to have 12 pi over 9. Now, just a little FYI, 12 pi over 9 can simplify to 4 pi over 3, okay? And then, let me see, so I did 0, 1, 2, 3. And then when n is 4, we're going to have 16 pi over 9. Now, if you're wondering, when do you stop? If you end up with 2 pi, you've gone too far. Okay, so you don't want to include 2 pi, so you want one less than 2 pi. So if you notice, this is 4/3 pi, so it's just slightly over pi. 16 pi over 9, it's basically, let's see, 1 and 5/9, so it's not even 2 yet. So this is 0, 1, 2, 3, 4. If n is 5, I'm going to have 20 pi over 9, and that's already going over 2 pi. So I'm going to stop there. So these are all the solutions for this one, okay? So 0, 1, 2, 3, 4, okay? So again, if n is 5, I'm going to have 20 pi over 9, and that's already past 2 pi. That's too much, so I don't want to include that one, okay? So now I can find all the solutions of this one. So when n is 0, then I should have, this would be 0, so this would be just 2 pi over 9. Okay, and that's not here, so I'm going to include 2 pi over 9. Okay, so 2 pi over 9. When n is 1, this is going to be 2 pi plus 4 pi, which is 6 pi over 9. And 6 pi over 9 can basically simplify to, let's see, 2 pi over 3. Okay. Okay. And so this is 0, this is 1. Okay, and then if n is 2, then I'm going to have 10 pi over 9, okay? 10 pi over 9. Notice this is slightly over pi, so we're still good, okay? And then if, so this was 0, 1, 2, and then if n is 3, we're going to have 3 times 4, so that's 12 pi, 14 pi over 9. Okay, and I'm running out of room, so let me grab my second whiteboard. Okay, so when n is 3, we have 14 pi over 9. If n is 4, then we're going to have 4 times 4, which is 16 pi plus 2 pi, which is going to give me 18 pi over 9. And 18 pi over 9 will give me 2 pi. And we don't want to include 2 pi, okay? So remember, we want to end at 2 pi, but we don't want to include it. So that'll be all the answers for that. So basically, I rewrote them in order. So we have, so far we have 0, 4 pi over 9, 8 pi over 9, 4 pi over 3, 16 pi over 9. And those are all the ones that the first one gave me. And then 2 pi over 9, 2 pi over 3, 10 pi over 9, and 14 pi over 9. Okay, so this is what I've written so far. But we're not done, because if you recall, all we did was find all the solutions for this one, sine 9 of x over 2. So we still have to go back and find the solutions for these. We want exact solutions. So we're pretty much going to do the same thing we did earlier, okay? So I'm going to erase this so you can either pause the video and copy this down, but I'm going to erase this, okay? Okay, so now we're going to do the same thing here, and I'm going to do it in a different color, okay? Oops, sorry, I moved the camera. Okay, so I want to remind you, sine of 0 will give me 0, and sine of pi will give me 0. So I'm setting each of these angle equals to 0 and pi. So, okay, so now I'm going to work with these angles, okay? So we remember 3x over 2 will give me 0 plus 2n pi. And then 3x over 2 will give me pi plus 2n pi. Basically, I'm writing a general equation, so if because it's going to happen multiple times between 0 and pi. Okay, so now I'm going to isolate x by basically multiplying by the reciprocal to both sides. So I'm going to multiply by 2/3, kind of like I did the last one, okay? Except it was 2/9. Okay. Now I'm going to be doing the same thing here. So I'm going to show you. So now I'm going to end up with x equals 2/3 times 0 will give me 0. So 2/3 times 2n pi will give me 4n pi over 3. Okay. Okay, so when n is 0, this will give me 0, but 0 is already one of our solutions. If you recall, if you look at your notes, 0 was already one of our solutions. Okay, so when n is 1, we get 4 pi over 3. But guess what? That was already one of our solutions. When n is 2, we get 8 pi over when n is 2, we get 8 pi over 3, and 8 pi over 3 is already past 2 pi. So basically, the two solutions that this gave us, we already had. So we don't have to find any more, okay? So we're done with this one. Okay, so now I'm going to basically do the same thing that I did earlier. So I'm going to multiply by 2/3 here to the left-hand side and the right-hand side. And I'm running out of room, guys, so that's why I'm doing it kind of funny. But here it is. So x equals 2/3 times pi, which will give me 2 pi over 3. And then here will give me 4n pi. Okay. Again, when n is 0, I'm going to have just 2 pi over 3. Okay. And yeah, when n is 0, I'm going to have 2 pi over 3. And if you notice, that's not one of our solutions. So we're going to include 2 pi over 3. So 2 pi over 3 will be one of our solutions. Okay. When n is 1, we're going to have 4 pi plus pi, which is going to be 6 pi over 3. But 6 pi over 3 will give me 2 pi, and we don't want to include 2 pi. So the only new solution that we're going to include is 2 pi over 3. So all together, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 solutions. And you know what? Earlier I said 2 pi over 3 was a new solution, and actually we had it here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 solutions that we're going to include all together. Okay? And that's it. So basically, I ended up doing the work for the second one, and it didn't render any new solutions, okay? But that was just me double checking, because it could, depending on the situation, okay? I didn't realize I had already written that one. All right, boys and girls, so now I'm going to have you guys try checkpoint on example 9, okay? Check your solutions, and again, if you have any questions, jump back in the chat.